1.4. 1.4. Simplify this expression. So the first thing you want to do is whenever you have a negative and a radical, you want to take it out. So this is going to become 3 minus I 198. Now how do we simplify 198? Well, we use the method we had before. We have to prime factorize it. I'm going to do this way instead of the tree. So we know it's even, so 2 goes into it. And this is going to become 99. 99 is divisible by, well, 9 for sure. We'll say 11. 11 is a prime. So 11 times 9, and then 9 is 3 times 3. So what we have here is that 198 equals 3 times 3 times 2 times 11. So if we do our little method over here that we learned earlier, we put a 3 here, and a 3 here. The 2, there's not enough to go around. The 11, there's not enough to go around. So our answer here is 3 radical 22. So this becomes 3 minus 3I radical 22. Because there's nothing else that's in front here. So 3 minus 3. We're going to try it. We're going to put no, we'll put the I at the end because that's the rules. 3 radical 22 I. Factor trinomials. So we want to factor this. So here we want to find out, we multiply the number here in front with the 44. Here there's just a 1. So we have negative 44. And what we're interested in is what factors of 44, negative 44 will add up to negative 7. So there's clearly, negative 44 and 1. Negative 44 times 1 is negative 44, but when you add them up, it's negative 43. What else is there? There's negative 11 and 4, right? And this happens to be negative 7. So this is what we like right here. This becomes x minus 11, x plus 4. Solve this equation by factoring. Okay, so here we're going to do the same thing here. 10 plus, now, we can start with 10 and 1, that's 11. 5 and 2, that's 7. That's what we want. So this becomes x plus 5 times x plus 2 is 0. Now we use here, it's called the ZPP, the zero product property. This means if A times B equals 0, then right away you have two different equations. One of them has to be 0. There's no other way. They could both be 0, but at least one of them has to be 0. So here we have x plus 5 equals 0, and over here we have x plus 2 equals 0. Just add or subtract the 5 from both sides. We have x equals -5 and x equals -2. -5 and -2 are the answers. Okay. -5, comma, -2. Using the square root property. So first thing we want to do here is divide. We want to get the x by itself, right? So divide everything by 5. And you're allowed to use a calculator, so this is 13. Now the square root property says whenever you have x squared, equals k, the answer is going to be x equals plus or minus the square root of k. So you take the square root and then you don't forget the plus or minus in front. So this is going to be x equals plus or minus square root. 13 is a prime number, so it's not going to have a square root. So plus 13, radical 13 minus radical 13. Now the only problem is there's no plus or minus here, so you're going to have to put radical 13, comma, get out of the radical, and minus radical 13. Decide what must be added to make this a perfect trinomial. So the rule here is you basically have a, well, in this case we're not going to have a, we'll just have x squared plus bx. Now what you want to do is you want to take half of b and then square it. Half squared, you'll see me do this probably on some next problems. Half squared. So here b is 10. Take half of that and then square it. So we're going to add 25 here to make it a perfect square. And what that means is basically this is x plus 5 squared. That's why it's a perfect square. So we're going to add 25. Use the quadratic formula to solve this equation. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing we got to do here is get everything, we got to set it equal to 0, so we're going to plus 6 to both sides. Now our a is 5, our b is negative 5, and our c is 6. So 5, negative 5, 6. Then you just plug it into this formula over here. So x equals negative 5, so that's negative 5, plus or minus the square root of b squared is 25, I just squared this, minus 4, a is 5, c is 6, and then 2 times 5, so we have 5 plus or minus the square root of 25 minus 120 over 10. I'll just do this right away. This is going to be minus 95. Minus 95. That, I don't think, that's 19 times 5. So that doesn't really factor. So this is and this can be an I because it's negative. So I'm gonna make some space for that. This will be I radical 95 over 10. And like I said, we can't really factor this out, so I guess that's our answer. Usually when you have a quadratic, when you're forced to use a quadratic equation, it's usually going to be something of this form. Otherwise you could have factored it. So our answer is 5 plus, this is all going to be on, well, we have a fraction. 5 plus, let's see if it just accepts it without having to be at the end. 95 over 10, comma, 5 minus, where did I go? Just type in I. Square root of 95 over 10. And I was right. Trust the math. Use a discriminant to determine the number of solutions. It says do not solve the equation. So we're not going to have to work it all out. The discriminant is basically, in this last part, this right here determines what kind of answer you have. Because you're taking the square root. If it's positive, you're going to have two numbers, because it's plus something minus something, so there's two answers. If it's 0, well, plus or minus 0 is 0, so it's only one answer. And then if it's negative, you're going to have two complex answers, so I'll write that down. So b squared minus 4ac is the discriminant. If it's greater than 0, you have two real solutions. If it's equal to 0, only one real solution. If it's less than 0, you're going to have two complex solutions. So here, b squared minus 4ac. So b squared is going to be radical 10 squared is 10 minus 4 times 2 times 7. This is 10 minus 8, 56. Now all you really care is that it's greater than or less than 0. So this is clearly going to be less than 0. So it's going to have two complex solutions. It wants to discriminate, so it's going to be minus 46. And it has two, well, non-real. Non-real is complex. And we're done with that section.